Okay, so here I started talking about this Unix directory structure, and we learned this root folder and other folders under that root. Like bin folder is for some executive commands, like they are putting here into the bin folder. Home will be your home directory. So when you ls home, like for example, I'll do it here, ls home, you'll see all the people in this cluster. See, these are their Unix account IDs. So, and here there are other folders. And as you can see, there are some levels here. So this is the root and home, and there is user one. See, there are 3 levels here, and there can be the 4th one here. So all this directory structure organized like this. So in the future, when you want to organize your own files, you will create some folders under these, for your home folder, and then under that directory, you can create more directories to organize everything you have. But let me show you what we have here. So when you do this ls/ first command, it will just list the root. So let me do it now. See, now I'm just gonna be here first to show where I am. Print working directory. So this is my home. This is my user ID. So this is where I am. When I log in, you're gonna land into your home directory first. And if you want to see where you are after you change your directory, you can always use this print working directory, pwd command. Okay, so we have a couple of different storage in our cluster. So first storage is your home. So when you use this command, df-h, so there's a space here, dot, so just learn this command, you're going to use this a lot. It is going to tell you how much space you have in that specific location. It's 50 gigabyte in my home. It's the same for everybody here. And I use 44 gigabytes of it, and I only have 6.1 gigabytes available. So 88% of my home folder is used. So this is pretty small storage. When you want to process your own data in the future, please don't use your home, because with a couple of samples, you can fill this up and you cannot process your data. Usually, if you have, for example, 10 samples, and each sample has, for example, 10 million reads, you might need at least half a terabyte or half a terabyte of storage to process that data. So you need like 500 gigabytes, not 50. So because you're going to see in the future when we are processing the data, there are many steps, many intermediate steps that will increase the space usage when you're analyzing your RNA-seq data or ATAC-seq or ChIP-seq. So make sure you have enough space before you start processing. So this, your home space is usually good for writing small scripts. Like for example, I'm writing my small scripts and putting into my bin directory. So there are some scripts that I'll show you later, that how you can actually write your script and run those. And also some other small things I put here, and when I don't use them, I delete them. Okay, the second storage is your project space, and the third one is the nearline. So we have this 3 storage. So usually if you are a PI, or usually your PIs already have a project space. So as you can see, when you do ls project, like ls/project, you can see many PI names here. It starts with UMW and end with your PI's name. For example, this is Garber Lab or Francesca Massi. So if you don't see your PI name here, so what you can do, there is a trick here that I'll show you. When you ls project UMW, for example, just write your PI name, for example, Kenneth Rock. So when I just start writing key E and N, for example, and tab, if it is there, it's going to complete. So tab key in your keyboard will complete all this words. So when you're writing a command, it's the same. So for example, if I want to write which command, see, I started with WHI, and then when I press tab, it brought me all possible commands. So these are all possible commands, which, while, and whiptail. So, but when you press C, see, there's only this one. When you tab, it's going to bring that command. So just learn these kind of tricks. Like tab is going to do this auto completion while you start writing your command. So in your project space, usually they give you up to 2 terabytes for free to your PI, and you're going to share this space with your with your people in your lab. So if you need more space, you can either increase your space in projects, or you can get extra space from Nearline. So Nearline is cheaper than project space. Their speeds are comparable. So I suggest you to get more space if you need from Nearline. Okay, so when you have the space, so what you're doing, for example, my space in here in project, I have UMW biocore. See, and when I do this df minus h and dot, so I have 3 terabytes of space. See, I have more space, and I use 2.7 terabyte of it, and I have 372 gigabytes more. Again, I use coincidence 88% of it. So when you're running your when you are using these spaces, so make sure to run this command df minus h after you go to that specific folder. So you need to change the directory to that folder, and then in that folder you can either write like this df minus h dot. Dot means wherever you are, you can use that dot, or you can run this command like this wherever you are. For example, when I just use cd, I go to my home directory. See, I'm in my home directory now, and when I use the df minus h command with this folder or any other folder belong to me, but there's always space in between here. See, df space dash h space the folder I want to check. See, this is going to give the same space. So when I do this to my home directory, even I'm there now, I don't need to, I can just use that, but I can still do this. See, this is 50 gigabytes, 44, 6.1 gigabytes. So you're going to use this command a lot, because when you don't have enough space, you need to learn how to remove some unused files. That's why you do this, see how much space you have, and if you think this space would be enough to process your data, then you can use it. But you can always go back there and choose some folders and remove them. But there's one thing you need to remember: when you remove the files, they are not recoverable anymore. So when you delete, they're gone. So make sure you're deleting the right files. Make sure you backup them somewhere into your storage in your laptop, or I'll show you how to copy these files from one location to another. But make sure you're not losing anything. So in our case, when I start introducing Dolphin Next, for example, we are just keeping FASTQ files and removing all intermediate files. And when we need any intermediate file in the future, we rerun the same run, because it's already in Dolphin Next. So you're just pressing run button if you need any intermediate file. Your job will be easier.
I have a question.
Yeah.
For the near line, you said for the directory for the near line, do we have to pay for storage, or how do we request space, or how it works?
So yeah, so Nearline is like project space.
Yes.
So, but there are less PIs here.
Yeah, I've seen that. Yeah.
Maybe are you here?
No. So
okay, but so when you need a space, extra space, you can get this space cheaper here. What you need to do is just send an email to HPCC admins, ask them Nearline space, and they will tell you the storage. For example, I just calculated the other day, like for 40 terabytes, you need to pay $10,000 per year, for example, for 40 terabytes, 10,000 per
$100.
year. So just, you know, when you ask them, I don't know, the prices might change. Maybe it's getting cheaper and cheaper every year. So just you can talk with them about the right pricing.
But in the nearline, all the storage is paid. It is not. If I request space, even like if I space request for 5 terabytes, I have to pay some money.
Yes,
For
yes.
this.
For any space, for 5 terabytes, you're gonna pay 2,000 per year.
Okay. Okay. And like you said, for the project space, we have a 2 terabyte as a because we are paying for the services. So we have a 2 terabyte space, right?
Yes, yes.
Okay, that is
You should
included.
have, but you need to ask that space, Ravi. If you don't have it, ask them. They're gonna create it for you, and up to 2 terabytes, it should be free unless
Yep.
a new policy.
So
I was like that
okay.
before.
Okay. Thank you very much.
Yeah.
Can,
So
can, can,
anybody?
I, yeah, can I also ask a question? So can you
Of course.
please explain in the tree, where are those spaces? Because I'm confused about home space, project space, this
Okay.
nearline space.
I will. I will. See, this is the root. ls/ is your root. And when you do this, home space is here. ls home, for example, my AK, this is my home space. See, this is my home under home directory. But if you want to see the NL, like nearline, it's here, NL / your lab name, UMW, for example, Manuel Garber is one of the labs. See? So it's going to be like this for you too. UMW, your PI's name or your name. So, and for project, it's the same in the tree. See, project, UMW, Manuel Garber, for example. Oh, Garber changed it to Garber Lab. But usually it's going to be the same, like UMW underscore your PI's or your name. So it's like this. It's at the top of the root, NL or project, and then your PI's name. Okay. Any other questions about this? So other
One
thing.
quick one. Is there any like effect on the processing speed or executing files? Everything is the same. It's just for the storage, right?
This is just for the storage. And
Okay.
we are using the head node now. So we are going to discuss about what head node is, what child node is, what cluster is in the next session. But today, I'm just showing some basic functions, basic commands to how to change your directory, how to get the list, how to go from one directory to another. So these are the things that I want you to understand. Like the question was good. Like, you know, you can be lost here unless you know where you are. For example, here, when you just use cd command, these are written here in this list. Like, for example, where was it? CD. Change your home directory. But when you just use the cd itself and then enter, sorry, and you are going to change yourself to your home directory. So wherever you are, for example, I'm going to go to this directory, cd project, for example, UMW Garber Lab. And I'm here now. See, I can show you that I'm here with using this pwd command. So I'm not lost now. So if I want to go back, either I can use cd, or there is another command here to go back to your home directory. It's called tilde, cd tilde. But there is always a space in between the commands, like cd, this is the parameter of a command, like tilde, or cd ... will put you into one directory above. So when I do this, pwd, I'm here in projects now. If I do ls, I'll see everybody's folders here. So another one is like cd /, for example, this is going to go to the root, and this is the same. This is cd dash will change to previous directory. So if I do this, see, I'm going to go back to my previous directory, UMW Garber Lab. These are very useful commands because sometimes you go to a directory like deep down in my storage, for example, cd project, I'll show you, project UMW biocore data, or no, I don't have it, data here, or Küçük data, and like, for example, geo. See, I'm here now. So there are lots of folders, lots of levels here. So when I want to go to my home, I can go there. See, I'm in there. But if I want to go back, you can use the CD dash. See, I'm back there. So sometimes moving from one folder to another in the cluster would make your job much easier when you want to copy files, when you want to check stuff in these folders. So these are, for example, some FASTQ files in this folder. So, and this, if you want to change the folder like this to project UMW biocore class, you can just write the full path. This is called full path of the directory. But also you can do such things like relative path, means like I'm here now, I just want to go one directory above or two directories above here, cd dot dot slash dot dot. See, it will make me go to this folder. And in that folder, if I just press tab, see, I see whatever I have in that folder. So data was there. So two folder above, data, geo. So you can use this dot dot slash dot dot slash. So I want you to get familiarize all these commands, because when you're moving around, when you run the things from command line, you will use these things a lot. That's why I put a couple of commands here. You can use cd, go to your home, pwd to write that working directory, ls to get the list, cd dot dot will put you into one directory above, like for example, I'm in geo now, I'm there now, and pwd, see, I was here before, and then I use this command, c dot dot, and I'm here now, one directory above. And when I ls here, see, my geo is here under this directory. So you're going to understand all this directory structure after you run these commands a couple times. Any questions about these? Okay, so this ls command or any other commands you use has many parameters that you can use. For example, when I use this ls itself, it's just going to list all the directories and files in this directory wherever I am. So when I do this ls minus l, so this is one parameter. Usually when you add a parameter into your command, you put first space, this is very important, and then you use dash l. This is just a parameter. It means that ls command will list the files with more information about them. In this case, for example, it is showing the permissions of that specific directories, the permissions of the files, and the owner of the file, it's me, and this file is owned by another user. And you see the sizes of those files and directories. This file size is 0, for example. And you can also see the creation date of that file. Okay, so we're going to talk about these permissions in a minute. Any questions about this ls minus l? Okay, so when you want to see what else you can use, what other commands you can use, so there's also help in these commands. Usually you write this help command, ls dash dash help. See, this is all other parameters you can use. This is a documentation about this command, ls command. You can do many things like ls minus a, b, you can read what it is doing. If you only want to list the directories in your folder, you just use, for example, minus d. There are many other things here. So I don't know, like if you want to recursively get the lists, means that all the folders inside of this folder, for example, here, see, it's showing all the files. There's another thing. When you run a command, if it takes longer than you expected, you can always use control plus C. You're not going to write this, but you're going to use your keyboard, control key on your keyboard and C key in your keyboard, and it will just exit from that run. So this was too much, all these folders, files in my in this directory, I just exit. So the other thing, sometimes you can stuck here. So like sometimes by mistake, you can just run this kind of command, like a code or this kind of things. So when if you end up with this symbol, you cannot, your commands is not going to work, okay? This is not the shell anymore. This is something in a different area that we use this for other things that you'll learn later. But if you end up here, just use Control-C again to exit, because you will feel yourself like you're stuck somewhere, your commands are not working anymore, okay? This is, you need to exit here using, again, Control-C. Okay, these are the things. Tree command is good sometimes if you just want to see. I'm going to go to my home space, an example just to show you tree command here. See, when I do tree, there are not many files in this directory, and I see a backup folder here, blue, a new backup folder, and there are a couple of files here. So in this folder, there are 2 more files. And then when you use tree, it's showing all these directory structures. Sometimes it helps you to visualize what you have in your folders. And when you use tree -d, it's just going to print only the directories in this folder. For example, just to show you, I'm going to create a new folder under backup. You can create this like new folder. I gave a new name. You use this make dir command when you're doing your tutorial. So when I run this, and then tree -d, see, this is also another folder I just created now. And you can visualize how the folders are looking in your storage. When you realize that, for example, I don't use new folder anymore, you can always delete them like this. If the folder is empty, you can use rmdir, or if there are some files underneath, you can use rm-rf this, and see, it's gone now. But make sure you're writing the right folder here. If you just write backup, for example, you can delete all your backups and you cannot get them back. So make sure you're using this command wisely, okay? You can always get your backups into a secondary folder before you delete, or make sure you're doing things right. Otherwise, don't delete anything. Ask us before you delete anything. We can help you a couple times, and then you're gonna get used to deleting your files, and then you're gonna be safe. You learn how to see the help with this -- help. In many programs, it's like this, but also there is another command to show the same document or manual. So it's man ls. So for any command, man which, for example, another command is which. See, you can see all the description of that command, the available options in that command. You can see all and some examples later. So this will help you a lot when you're learning Linux, okay? When you're using any commands here. So in this case, for example, I want to see where ls command is. Which ls? See, bin ls, the ls command, my ls command, or anybody's ls command in this cluster is located under this directory. So I can also show that command itself using ls-l. See, you can see some information about this command. Here, the size of the command, the file size of the command is 117 kilobytes. So you can see the command. And this command is copied here, 28 November 2017. So this is important because sometimes you create a file. For example, I'm creating a new file, new. Touch means just creates a new file with this command. You don't need to memorize these things. But when I just create this empty file, see new. As you can tell, I created it today, 8 April. This is 1036 new file, and it is empty file. It's zero. There's nothing inside of this file. So you can see and follow some of the files you created by looking their dates using this ls-l command. And there is another thing like h command. You can use this h. This is available for many functions. And when you use ls-lh, it's going to print, like maybe I can do it here, ls minus lh. See, but there's nothing big here. But it's human readable format of the sizes of the files. So, see, for example, here, some files are 11 kilobytes. If there is a bigger file, like megabyte file, for example, 1.9 megabytes, it's not, when you don't use the H, for example, here, it's just writing in bytes, 195, whatever, 1950 kilobytes, whatever. But it's sometimes harder to read these. And then when you do like this, it's much easier to read the file sizes. So I guess you learned moving around the storage, and you learn how to create a folder and how to change the directory and print that working directory. So you can go this couple times, delete the files, delete the directories, do these things a couple of times and change your directories to learn everything here. And when you're copying the files, for example, you have this command called cp and space again, and first part of the file or directory is the source file. The second one is your target directory or file. So when you use this command, it is going to copy this func.r file from this directory to your home directory. This tilde was your home / bootcamp first. Either you can use this. I'll show you a couple of things here just to follow me here, that they're all the same thing. See, for example, I'm going to go here first. I'm in my home directory, and I already created my bootcamp folder here. Okay, it's in my home. So tilde bootcamp. So when I do this tilde bootcamp, see, this is the same. ls bootcamp, ls tilde bootcamp are the same. Or when I use the full path, home 97w bootcamp will be the same too. See, they're all showing exactly the same directory. So this is the relative path, means I'm in this folder already in my home, and I'm just doing ls. And tilde, it's my home. This denotes home, this symbol tilde, and then /bootcamp will be my bootcamp folder in my home directory. So you can create this bootcamp folder in any other directories too. So for example, I can create a bootcamp folder under bootcamp. See, just, I don't want to make things complicated, but you can still do these kind of things. See, when I use tree bootcamp, oops, there are other files. But I'm just going to use the directory, print the directories. See here, I have bootcamp folder here on the top, and I just created another bootcamp under this. So these, sometimes you do these kind of things, but you have to be sure where you are by, for example, going to that specific folder. And when I do pwt, see, I see bootcamp. Under bootcamp, I have another bootcamp. So I'm just going to remove this. But you can always do these kind of things. But I want you to be aware of where you are every time when you're copying your files. When you see these names like again and again in other places, when you're copying files from one location to another, make sure you're choosing the right file from the right location, and you're choosing the right target location and copy there. So how we do it, for example, cp, I'm going to copy one file from this directory class, for example, funcs.r. This is just an R file, but I want to copy this file into my, like, for example, bootcamp folder. So it wasn't there. In my bootcamp folder, there are only these two, one directory and data TSV file. But when I copy this file from there, from this location to my target location, like this, and then when I ls my bootcamp, see, funcs.r came here. So are here now, sorry, is here now. So what I'm talking about here is, so when you want to get a backup of your file or script or anything, you can always use the cp, and your files or a directory. You can also copy whole class directory, for example, from one location to another. So here you're going to learn here in this line, if you use this -r, means recursive. So for example, I'm going to just copy this file, cp-r, all this class directory, whatever in it, inside of that directory will go to my bootcamp. Okay, when I do this, it copied everything now. And I was already here, by the way, on bootcamp. So when I do either like this, bootcamp, see, class folder wasn't here before. So it wasn't here before. And then after I ran this command, what I did was I copied all the class directory recursively. So when I do tree, for example, to class, see, all the files under class are listed here. So when I just do the D, for example, -D, see, there's class and sorted directory. I just get the tree of all directories in this list. So these are the things that you are going to learn when you finish this. And when you want to remove a file, again, you can either use this rm function, the file name, or if it is a directory, either you're going to use, if it is an empty directory, either you're going to use rmdir first, or you can use this rm-rf, that directory. So I'm not going to do them. You can repeat, but again, please make sure you're writing the right folder name here that you want to delete. You don't want to delete something you're going to use in the future, or if you need a space, you can copy some of the files into your backup space to nearline, for example, and then you can delete your files. So if you are sure that you're not going to use any more, then you can delete everything in that folder. And there is another command called move. So you can move one directory or file from one location to another. This move command can be used to rename a folder, for example, too. So what I'm going to do, for example, I'm going to create a directory here now just to show how it is working. And I'll show you, I just created this dir1. And I'm going to use move function to dir1 to dir2. Means I just moved it, or I just changed the name of that dir1 becomes directory 2. Sometimes you need to do this, organize your files by changing the names, by moving from one location to another. So this is same thing like, you use cp command, but it is doing this move. Move means it is removing the old version and moving it to a new location. So see, dir1 is not there anymore. So if you want to keep the old one, you can always use the cp-r. For example, I had this dir2, and I want to keep dir2, but I want to get a copy of it into the same directory like this. See, when I do this, they're both there. So if you want to, I know these are empty, so if you want to remove them, you can just use dir1. Or if you want to remove, let me show, this is gone now when I use this command. And if you want to just remove the second one, you can just use dir2 like this. See how you move the files, how you copy the files, remove the files and directories, copy files recursively, everything is noted here. So if you want to remember things, just come to this page. It's going to stay here, and you can repeat all these commands and learn. So there is another thing that I want to talk here. So there is command more, or head or tail, or cat. So these commands are important when you want to monitor what you have in the file, when you want to see what you have in the file. For example, I want to use my tree command, okay, tree -d RNA-seq, for example. So if you want to put the command output to a new file, you can use this symbol, okay? If you use this, whatever the output of this command, it could be anything. It could be ls, it could be tree, it could be any command. But if you want to put the output of this command into a file, like for example, my tree, I just give a name to my file. See, it's not going to write anything to the screen now, as you can see. What it is doing, all the things, like all the output was this, okay? This output is inside of my file now when I use this symbol. Sometimes you need this to put the things into a file and then keep there for your records, or sometimes the output you need to share with other people. You put the output into a file like this and to see it later, for example. So to see what you have in this file, you can use this more command. See, when I do more, my tree, this shows everything in this file. If I do like this, more, or cat, let me show like cat, my tree. But be careful when you're using these. More is okay, but the cat, if the file is big, like a gigabyte of a file, for example, when you use cat, it's trying to dump all that file into the screen, and it's going to take forever. So you need to use Control-C to exit. So, but what I'm doing now, for example, if I know that the file is small, how you can understand if it is small or not? When you can, when you use this ls-l symbol, you're going to see this. See, only 438 bytes. This is a small file. But when I want to show what I have in a bigger file like this, for example, I know this file is big. I'll show you another command, for example, wc-l. This is going to show how many lines you have. This is called word count, the name of the command. And when I do this, it is going to tell me, like, in this file, I have 30,000 lines, 30,740 lines. So if you want to see what you have here, you can use this more command. See, this is going to show the file, whatever you have inside, page by page. So it's going to stop in the first page. And these are the genes, for example, transcript names. And for each column, you have the transcript or gene counts, for example, in this file. So, but it is going to show, more command will show this page by page. But when you press Q button in more, Q, like Q, in the keyboard, it's going to exit from there. So you can try Q. Or when you're there, if you're stuck somewhere, you can always use Control-C to exit, Control-C. So if you feel yourself stuck somewhere, please use Control-C, then you're going to end up into this command line, and then you're going to be all safe, and then write your other commands. So the two things that I want to show about this more, and another thing, if you want to just print first 10 lines of this file, you can use head. See, this is the first 10 lines. Or in another file, I'm going to use head data. See, this is the first 10 lines of that file. Sometimes you want to see the last 10 lines, and it's tail. See, this is the last 10 lines that if you want to see. Or if you want to see 20 lines, you can use -n. See, this is another parameter, and 20. So this is going to be 20 lines now. Sometimes you just want to test some genes, and you can always use this, head and tail. And cat, I showed the cat. Touch is going to create an empty file that you're going to learn that. And okay, now I want to show you the file permissions, so what they are. So when you do this ls-l in any directory, it's going to show these columns and list all the files and directories. So to see if a file, an entry here is a file or a directory, you can check this this column. So here, for example, if it starts with D, it means this is a directory. If there is no D there in the first character here, it means this is a file. So as you can tell here, these directories and files has different permissions. So what they are. So the first three permission belongs to the user. So if you want to share, if you don't want to share this file with anybody, you can just set this this part of that permission of the file to read, write, and X. So this read is, if you just want to give the read access to the user, you can just you give the R letter, but I'm going to show you how you can change the permissions later. But user means this belongs to you, okay? Only you. If you change this, this will only be accessible by you and by the root user. Root users, in this case, for example, in the cluster, I'm not a root user here. So I cannot access your files if you don't share that file by setting up permissions in this others. If we are in the same group with you guys, then you can we can change this part of that permission, and then if we are in the same group, we can share files using the permission group. For example, the people in your lab will be in the same group with you, and if you just don't want to share anything with others, but only with the people in your lab, then you're gonna play with this part of the permissions of the file or directories. So, but if you decide sharing some files with other people in this cluster system, for example, there are some files I share with everybody and I give read writes, but I don't give write writes, because read writes are only things to read whatever inside of the file. For example, when I do head, I'm reading this file now. Or when I do cat, I'm reading the file, but I'm not changing that file. But if you want to give permission to other people to change the file, delete the file, for example, this is risky. You have to be sure who you are giving these permissions. They can delete your files. That's why usually the second part of this is like dash usually. But how we are doing this, let me show you. So here you have user, group, and others. And this is if you want to give only the read writes, for example, to a file. So you can do like this, change mode plus R my tree. But these write writes were already there before. So I'm going to remove the write writes with -W. See, when I do this, see, I could remove that write writes from everybody. Even I cannot write this myself. See, for example, if I want to delete this file, I cannot delete. Or if I want to change something, see, I just use an editor and shouldn't, but I am the owner of the file. That's why I can do anything, but nobody can actually access the file and change anything in this file. But again, when I do this, see, it says read only. So when you give the write permissions, again, you can change like this, plus write, or in the future, we're going to see some commands. For example, I just want to put this ls-l command into a file, for example, L. The name of the file will be L, okay? What I'm doing, I just do this echo ls-l into L. This means I create a shortcut, for example, for this command, and you're going to see how I am actually executing this with L. This is another thing you're going to learn. See, when I do this echo ls-l, this symbol into L, this is going to write this command into this file. And when I use more, I see what it is inside of this file. But this is a command, and this is like how you can actually write your scripts in the future. But I just simplify this ls-l with L command. But when I want to run this L, execute means like when you do this ls-l, command, when you press enter, this is doing that operation, so executing this command. So when I do this in a file like this, I have to run it like this. Try running like this with L, but it is not going to run this now because L doesn't have this executable rights here. See, there is no X here. So when I do this, see, permission denied. So if somebody sends you a file, a script in the future that they can tell you that, okay, run the script and get the results, send me the results back. So when you run, if you see this permission denied there, it means you don't have executable rights of that specific file. To give this executable rights, you can use this plus X L. So when I do this and then ls minus L, see, now I have the X everywhere. So everybody can run this now when I do plus X. If you want to remove the executable, you're going to do minus X. So when I do this dot slash L, see, it's running this command. So why I showed you this, in the future, when you have like huge commands, if you just want to simplify that command like this, you can just do echo that huge command, whatever it is, and then put into a file, give the executable rights, and then when you run it like this, it's going to run. So I usually put these kind of files into my bin directory. I'm sorry, my L, and I will put it there. And when I do this ls bin, see, L is there. So when I do L now, it couldn't find there because it's not here anymore. So where it is, it's here in bin L. See how you can, it's my home directory, bin L, because I moved that file into my bin folder. So, and I keep them there when I have, when I want to rerun same command in the future, I just move it there like this. So they are all written here, but there's also another thing that, for example, if you just want to change the rights, the permissions for the user or others or the group, you can use like this. O is equal to R. We'll just change the read permission only for others. In this case, it will give others RWX, for example, 3 of them together. So, or if you put G here, it's going to change for the group, like here, the group part. And if you just want to change it for yourself, give an executable rights, for example, for yourself, you can just change it with U. This will be U is equal to RWX, R, or nothing. Okay. So if you want to understand more about, there are other ways of changing this using binary information. Like, for example, you can change like change mode. You can use this command again with 777, for example, to give all the rights to the file. So there are also other ways to change. 777 means I gave all the rights, like read, write, and executable rights to that file for everybody, my group and everybody else. And it becomes like this. So, and I use the 777. For example, I just want to give, I want to remove the executable rights. I can just give the 666 my file. But I don't want to go to details about this because there are other things. See, I just removed that execution from everybody. So, but if you are curious about this numerical system to change the change mode of the files, you can click here and then understand the permissions better here. But if you are curious about it, I can also create another session to talk about it. So I think we are good now about the permissions, and please ask your questions now, and then you can continue the rest till the end today. And you have a homework you can either do here or home, and you can ask your questions after you finish this. I'll come back and tell you more stuff about these things.
So I have a primitive question. Some files are in black, some are like in white, some are in purple, some are in green.
Yes.
What is the difference?
Yeah. So, okay, let me share again. So those are about the permissions actually. So, or if they are directories or not. So as you can see here, if the directories, if they are directories, you see them blue. See, class and RNA-seq directories are blue. But if those are files, usually if they don't have executable rights, you see them white like this. They don't have executable rights. But if you give them executable rights, they turn to green. It means you can run them from command line as a function. So I showed you, like, for example, if I show my command I created for you today, L command is green now. See, or all the other things, minion, for example, another command I'm using. See, when I just write their name like this, they become executable and it becomes a command. And but if you don't want them, anybody to run them, for example, this was executable, but if I remove this, change mod, I don't know, I'm gonna remove -x, and when I try to run it, see, permission denied. The file is there, but I cannot run them anymore. So when I do this, sorry, ls, I'm just gonna do ls bin just to show you the color. See, minion is white now because it doesn't have the executable rights. I'm just gonna give back, sorry, plus x. So bin, it's here. See, it's green now. So one more thing I wanted to show you actually before you go to the next session. There were some modules that we are going to actually revisit that next week, but I want to show you, where was it, module? Okay, here. So in our cluster system, they installed a modular structure. Means, for example, when you want to have multiple versions of the same software, you need this modular structure. So in our system, in our cluster, but this is not the same in any other cluster, by the way. Sometimes they use, sometimes they don't. So, but in our cluster, they installed this system. So to see what software installed in our cluster, you can use this module available. So this function, this command, and this will tell you all available programs. See, there are so multiple versions of R, for example, exist in our cluster. Sometimes if you want to reproduce your results that you ran a couple years ago, for example, you run them with R 3.2.0, for example, this version. But we have a new version of it. In the same system, to accommodate multiple revisions or versions of the same software, you have to use this system. How we are using is like this. So for example, for star, you can just write module load star, and then when you, oh, maybe star is lowercase. Yeah, it's also important to use lowercase. Okay, module load star. So the module name star starts with star, and then when you press tab, it is going to give you all available versions with star. See, we have star 2.3.0, we have star 2.7.6a. So this is important because sometimes you want to reproduce other people's data and they are telling the version of the star, and you have to load the right version to get exactly the same mapping that they did while they are doing their data processing. So that's why you can load one of the version. For example, I want to load now 7.5a. I already loaded this version. See, it's not working. So what I need to do, I need to unload if any loaded version. How you can see the other versions? So you can use module list. See, This will tell you loaded modules into your system. If you want to load another version, you need to unload this. See, this is important. So what I'm going to do, for example, I'm just going to unload this with module unload. In your case, most likely you didn't load, or if you load, if you want to change the version, just unload like this, module unload. And now if I load this, another version, see, it's loaded now. This version is loaded. And how I can run this before, for example, I'm going to show this 2.7.5a. To run this command, I'm going to unload this just to show you it's not in my path. Means it's not executable. I don't have, see, start command not found. So if you don't load this module, you cannot run this command. So in that, people decided to use this capital start for to run the software. So, but other, like for example, when you run bowtie 2, it's going to be like lowercase, for example. It's whoever wrote the software can decide the if it should be capital letter or lowercase. So here, for example, when I load this module, and the location of that command is here. So if I ls here, oops, sorry, if I ls here means if I get the list here, the folder is here. See, star is under bin directory, the executable file. So just to see the rights, see, I'm going to show you the rights. See, read, write, executable, read, write, executable, read, write. See, I don't have this. I don't have that write privilege to delete this file. So if I want to delete this file, like let me show you, if I try to delete this file, it's not going to allow. See, remove write protector regular file. So it's not going to allow me to delete this file. See, permission denied. So I don't have the permission to delete this file. So if you don't want to delete files by mistake, you can change the permissions like this, and then you cannot delete them. So in this case, permission denied. And if I do this ls-l to this folder, the file still be there. So if you want to run this file now, star, if I just enter, see, star command is here now. See, usage, it's telling me how to run the command. So this is the index file. We're going to learn this next week. And read files, input files. This is paired and file. We're going to discuss these things next week. And you can run the star command like this. This is how to use. And if you want to learn the details, because star has many, many parameters, and when you start help, you can see all the things. There are many parameters here. By the way, when you run this, there's another thing I'm going to show you. There's this pipe symbol in your keyboard. If you use this, you can actually use another command here. For example, more, and it will print the help page by page. See, it stopped in the first page, and then another one, another one, another one. Okay. So you can always, if you see it's big, you can always star minus help. This pipe, this is called pipe symbol, and more. Okay. So the class will end at 12. I'll give you half more hour now. I think you can finish the rest of it, and it's up to you. If you already finished them, you can work on your homework, or you can do your homework like later. It's up to you. Okay, I'll be back in half an hour, around like 6:45. Oh, sorry, it's my 6:45. Sorry, around 11:45. Sorry. Okay, if you have questions now, you can ask on Slack, and we can also do one-to-one connections too. If you have questions, if you couldn't solve by texts like this on Slack, we can call you guys, or you can call us, and then we can share the screens and then help you like that too. So don't be shy. There is no stupid question. Please, when you're learning these things, you can have many different questions. I don't want you to stuck anywhere. Just if you need attention, please tell us. We'll connect you guys and solve your problems.